Okay, hi, my name is Frank Wierzbicki. I'm the lead developer of Jython, and so today I'm talking about Jython and the JVM. Just a quick. Okay, so the other day, Charles Nutter, one of the JRuby guys, asked me about some history. He was comparing how old JRuby was, or what their first repository check-in was. So for fun, I poked around it, and of course I found our first check-in from 1997, and of course you all know which Huguenin this would be. And so it was fun, so I poked around some more, and I found this one. So there's Guido van Rossum checking into Jython, also in 1997. And, you know, it's fun. I thought I'd start with that. So anyway, currently Jython is in we're targeting the 2.5 CPython, just like IronPython is moving to. Our numbering reflects the version of CPython we're attempting to emulate. We should be getting to a release candidate within a week or two. Unfortunately, I've been saying that for a few weeks. Some of the bugs in our one of the bugs in our list of final bugs turned out to cover a big mess that it's going to take us a little longer. I'm sure everybody's had that experience. Okay, so a few notes about the Jython's core. We use Antler. It's a recursive descent parser generator, pretty much the de facto standard if you're going to use generation in the Java world. We use ASM for emitting bytecodes, and it's probably the leading bytecode generator if you're going to use if you're not going to just do it yourself. Something I want to point out about that is Antler and ASM are projects that grew up in just Java's open source ecosystem. It wasn't something created by Sun or IBM. It's particularly Antler is almost the work of a single, I think pretty much the work of a single individual who's spent 20 years thinking about recursive parser generation. I'm sorry, recursive descent parser generation, but it's great to use. So a cool thing about Python 2.5 is they added an AST module where you can just pretty much emit the AST that actually gets used in the real compilation process. And so I implemented that in Jython, and I was able to directly compare our AST to their AST one for one, and just spent a few weeks diffing until things started to look pretty much the same. And other than a few little oddities with floating points and so forth, we're pretty much the same. The libraries are written in Java and Python. We're using JNA POSIX to kind of grab into the operating system now. Previously, we were doing just nothing. If Java didn't do it, Jython wouldn't do it. But we've decided that Python compatibility is nowadays more important to us than being strict Java. Yeah. So we're actually noticing when we're on Unix or Windows and doing a few of the things that you can do when you're on a particular operating system. Something that's important to note about our compiler and runtime is that we always put out bytecodes. Even eval, even exec, we generate bytecodes, we push them into a class loader. We never interpret is what that comes down to. Even though it's not always saved to disk. And of course, if you know about Python, pretty much the compilation process is triggered by importing. Whenever you import a module for the first time, that's when compiling gets triggered. So method dispatch involves lots of crazy stuff. When you say I want to call the B method on A, you'll first look in the objects dictionary, and if it's not there, you look in the classes dictionary. If it's not there, you go up the superclasses, and even then, users can put in descriptors that define the GET protocol, and so even if you do find something, you might still be calling more things on it. And what I'm trying to say is that Python's dispatch mechanism can take an awful lot of steps. It can hurt performance, and that's why one of the reasons I'm so excited about John Rose's work and method handles. We can perhaps, in a lot of cases, just do that once and then start doing things fast. We have even more trouble with Java because there aren't because the mismatch between Java and Python calling semantics is so weird. We have to actually generate a bunch of bytecodes, coerce a bunch of stuff from Python, go through this proxy, finally hit the Java, pull it back, wrap it again. And so we've got a lot of performance problems there as well. And again, a lot of the MLVM DaVinci project stuff is going to help with that when I finally get my release out and I can start working on cool things again. And here's a bunch of course, here's the cool things. Anonymous classes, invoke dynamic, method handles, all the stuff that John Rose has been talking about. And one really cool thing about this particular point in history is that Python is going into a 3.0 version where they've allowed some amount of backwards incompatibility. They didn't go crazy, and I'm not going to go crazy either. But one thing that I can do is I can say Jython 3.0 is only Jython 3.x is only going to run on JDK 7, so I can just use all of that cool MLVM stuff and not even have fallbacks when I'm first trying it out. Then we'll probably backport some of that stuff to the 2.x series, and then work on getting a backwards compatible fallbacks and so forth. And of course, some of the advantages of anonymous classes means we can stop doing all sorts of nasty name mangling that we use so that we don't conflict with names that exist. A horrible thing is right now we have a class loader per generated blob of code because it's the only way that we can be sure that we can garbage collect everything. So every single thing that we generate, that's another class loader, and it's very heavy. And again, invoke dynamic and method handles will again, we'll be able to get rid of those giant proxies over the Java and just use really simple standard code. And everything will be pixie dust and fairies. Yay. So another of our performance problems is that every time we make a call in Python, we create our own frames because you've heard the Iron Python guys say that they can't do the PDB because of some of the strangeness that happens in CPython. We implement some of the strangeness, which is that you can grab a frame at any time, shove local variables into it, and so it makes it very difficult to use the existing native stack frames. And so we're also thinking about that. We're going to look at doing static analysis and mainly static analysis and so forth to see where we can stop doing that. Right now we're doing it all the time. No matter what, we always make a frame for every call. And we're quite sure that we could do a whole lot less of that with a little analysis. Oops. One click too many. And here's some places to find out more. And I don't know whether I went too fast or too slow, but questions?
So, do you wrap all of do you wrap all types in a kind of PY object then, or do you use native types for things like strings?
Everything currently gets wrapped in unless you're calling it to Java, everything gets wrapped into PyObject, and we have a specific PyObject that has a PyString, and so we're not as far along on using native objects as IronPython is. There's also, of course, interface injection that. If that manages to make it into JDK 7, we could very well start using Java lang string for our string and so forth. And so I forgot to mention that one. But that's all featured. Right now, it's all wrapped.
Quick question about the interface injection that I had meant to ask earlier during John's talk. Does that actually allow you to attach state as well as the interface? Or then you need to maintain some sort of separate mapping from the actual object onto whatever your specific state data for that object is?
Oh, John handled that question.
By currying it into the method handles, but you can't attach, you don't visit each object.
Okay.
Anybody else? Oh, yes.
Are your AST tests that you mentioned, do those ship with Jython?
My AST tests are a thing that dumps out a big string. And then I can dump out the entire string of an entire library, which I just point at 2.5, and I literally diff them. I should make it more sophisticated, but at the moment, it's not. But I can, if I do, I'll let you know when I get. I definitely want to make that into a regression test, and when that happens, I'll let you know. It's really nice. It's nice for being really compatible. Anybody else?